Okay, I think it's time to start now. Hello, everyone, and welcome. This is Adel Tahir, OPA Business Developer, and I'll be the moderator of this session. At first, I would like to welcome you to this amazing webinar titled The Coiled Tubing Applications and Intervention Comparative Analysis, presented by our instructor engineer, Mahmoud Tarek. Mahmoud Tarek is a seasoned petroleum engineer with over 11 years of experience in the oil and gas industry. His trajectory encompasses a diverse range of roles, including 2 years as an offshore production platform operation manager and subsequently 10 years as a well intervention engineer, specializing in coil tubing and slickline operations. He excels as a well site leader for rigless offshore coil tubing interventions, as evidenced by his recent publication on a successful rigless coil tubing campaign at the 2024 Egypt's conference. Furthermore, he possesses a proven track of he possesses a proven track record of delivering comprehensive training programs on coil tubing and slickline operations to a wide audience, ranging from novices to seasoned professionals. Before we start our session, I'll make a small presentation about OPA upcoming services and plans. Here is our wave of live courses. We have already conducted reservoir simulation, OSHA general industry, and Power BI. There are 4 more courses in this wave, starting from coiled tubing operations that will be presented by the same instructor of today's webinar, Engineer Mahmoud, and it will be on the 11th of January, next Saturday, I believe. And carbonate reservoir modeling, which will be at the end of this month. And we will end the wave of live courses with BCB and NMR interpretation and theory in February. You can scan this QR code to register in our upcoming courses. Here's an amazing offer. Enroll in our enroll in our next live course, Coiled Tubing Operation, that will be conducted on 11th of January, and also get the recorded course titled Advanced Well Intervention Operations, both for 180 instead of 270. You can enroll in both courses and save $90. Here's also a reminder of our New Year discount, 60% on all our recorded courses and 70% for OPA ambassadors. We will know later how to be an OPA ambassador. So there are 2 days left for this offer. You can check our list of recorded courses here. You can also scan this QR code to register in our recorded courses using the New Year discount. I will send the promo code in the chat box right now. So make sure you seize this chance. You can use this QR code that I sent in the chat box in the cart checkout to enjoy 6% discount on all our recorded courses. Here is one of our best services, which is a mentorship program. It's a one-to-one mentoring sessions by highly experienced mentors. It's tailored based on the mentee's needs. Your requests can include practicing on how to produce output results from a software, guiding on personal data, professional guiding for PhD and master, helping undergrad students in their projects. We have already completed 45 mentorship program with more than 900 learning hours, and the mentees were from 8 different countries. You can scan this QR code to apply for a mentorship program. So here's our website. It's www.opacourses.com, where you can access every single services we provide, whether it's a webinar, live course, enroll in live or recorded courses, and apply in a mentorship program, or even apply for internship. Every service we provide, you can access it through our website. So make sure you pay it a visit. And finally, how to be an OPA ambassador to get there are two tracks to join our OPA ambassadors community. Take one or more courses or take a mentorship program. So you may be asking yourself now, what will I get from being an OPA ambassador? You will get discounts on all courses in the future and group discounts when you invite your colleagues. Thank you for listening, and now it's time for our session. Engineer Mahmoud, the time is yours. The mic is yours. You can start sharing now, Engineer Mahmoud.
Thank you, Engineer Adil. Is the voice clear on the screen
Yes,
also?
the voice and screen are clear.
Bismillah. Assalamu alaikum. Good afternoon, everyone. Thanks, Engineer Adil, for this valuable and informative introduction. I would thank all of you to attend today's webinar that I hope to add to your background and to be enjoyable, inshallah. So today we will present our webinar titled Coiled Tubing Application and Intervention Comparative Analysis. This session is designed, inshallah, to be educational and interactive. If you have any questions, feel free to ask. And I also give a Q&A session at the end of this course for any questions. Today's agenda, we will start with an overview of oil intervention technique. Next, we will compare the coiled tubing with other techniques, the advantages and main strengths of coiled tubing. And next, we will discuss guidelines for selecting the appropriate method, which is well intervention method, I mean. And then we will do a deep dive into coiled tubing. This will be followed by one or two case studies. And at the end, inshallah, we'll have a Q&A session. Okay, let's start with the definition of well intervention. What is well intervention? Well intervention refers to any operation performed on a well through its productive life. Everyone knows that any well have three essential phases: drilling phase, then completion phase, and finally the production phase. So any tool that be lowered into the well during the production phase, it will be a well intervention. Intervention means here the entry. The word intervention means entry. So a tool will enter the well, which means lowering or running hole with subsurface tool to perform an operation. It's called a well intervention. Why do we implement a well intervention? This will be showed on the next slides, but the main cause to enhance production and to save the well integrity of the well. So what is the most common techniques used in well interventions? We have wireline, coiled tubing, and snubbing unit. The most common well intervention techniques, wireline, coiled tubing, and snubbing units. Wireline have four types: Slickline, E-line, braided line, and digital Slickline. All those are called wireline. And not only Slickline is called wireline or E-line. No, the all four types, Slickline, E-line, braided line, digital Slickline, called wireline. Wireline, coiled tubing, and snubbing, all the types of well intervention. Each technique has a unique application and advantages that we will explore on next slides. Okay, let's break the ice by a question. Can anyone tell us in chat box or by voice what is the difference between well intervention and workover? If anyone can tell us.
Okay, you can simply raise your hand and I will open the mic for you, or just type in the chat box.
Hello.
Okay, go ahead, Emily.
Yeah, thank you, sir, for the privilege given to me to answer the question, sir.
You
Looking
are
at I think one of the differences between workover operation and well intervention, the workover operation has to do with you trying to revive a dead well. Are you getting me? A dead well.
Yes, yes.
While for the well intervention, you are working on a live well.
Yes.
A well that is still producing, but the production rate has really declined drastically, and you want to revive it. But for the workover operation, the well is dead already; it's no longer producing. But you want to let it to be producing, and in that case, it involves a kind of a rigorous activities, the workover, because you have to remove the completion and install a new completion for the well to be restored back into production. Thank you, sir.
Yes, thanks for Emily, Peace Emily, for this great answer. We'll back to our presentation. Yes, as Emily said, the main differences between well intervention and workover. Well intervention implemented on live wells, and workover implemented on killed well. Live well, it means not open or closed well. No, it's capable to flow, whatever it's open or closed. Live wells, the hydrostatic column in the well bore be lower than the reservoir pressure. The killed well, we introduce a hydrostatic column to overcome the reservoir pressure through the well scale. The main differences also we introduce in well intervention lightweight tools such as wireline, coiled tubing, and as we mentioned, for workover, we introduce to the well heavy duty equipment using a rig. And also in well intervention, the duration will be shorter and the cost lower. But in workover, the duration is longer and higher cost. For surface control, we use PCE, pressure control equipment, on Christmas tree for well intervention. PCE on Christmas tree, which is pressure control equipment, in some lubricators and pipe joints to contain the pressure over the well. In workover POP without Christmas tree, in most application without Christmas tree, there is no Christmas tree in workover. Is it clear? Okay, what are the main key reasons for well intervention? What is the main reason of well intervention? The well intervention main reason is the production decline. As we see here, if you are a production engineer in your company and you have a well issue, you have the decision to take the well intervention method to implement your well intervention method to solve the production decline effect. The production decline problem can be solved using one of well intervention techniques. So if you have a producing well, for example, 2,000 barrel oil per day, and then gradually after testing the well, you have found that the production is lower to 1,000 barrel oil per day. So from 2,000 to 1,000 barrel oil per day, so what shall you do as a petroleum engineer? You must find out the main cause. Here is the importance of well intervention. Either sand or scale deposition inside the tubing or accumulation in the reservoir. So you should to remove them using one or more of well intervention techniques, as we see in the next slides. If there is water cut increased, you should do a water shutoff or a reperforation. Let's have a look on this well. Okay, if you have what is the meaning of water shutoff? The concept of water shutoff, isolating the formation interval that contribute with high water content, as we need to shut this interval off. As we see here, the formation, the producing formation, producing oil and water, gas, oil, and water. So if the water content is increased, whatever the reason of the water source flow behind the casing from here or flow from any underlying formation from here, so the water is invading this producing formation and the total water cut increased to the surface. So what can we do in this application or in this problem causing a production decline? You must firstly run with something called PLT. What is PLT? Production logging tool. Run in whole with wire line, electric line, I mean. Wireline tools are deployed for this well, pressure and temperature sensors to read pressure and temperature of the formation, flow rates, and which specify the contribution of the water from which interval to know the water content where it's come from. So which is called hold up. And to know the exact interval location of water source. Secondly, after PLT, you may insert something called through tubing bridge block. This bridge block is seated here to isolate the interval from water coming, and after that we dump a cement to isolate, which is called cement plug. Cement to isolate the whole region of the water is coming from, and finally you may reperforate again in this region to reach to the migrated or displaced oil and to perforate non-invaded or pure formation that is highly saturated with oil. All this means of application, PLT, through tubing, bridge plug, cementing, and reperforation are conducted by wireline tools and coiled tubing tools. So the well intervention is very important in that case. Referring to the well intervention reasons, as we said, production decline will also the reason that may lead me to do a well intervention application, the well stimulation. What is the well stimulation? Well stimulation is bypassing or removing the formation damage. The formation damage caused by any reason, mud filtrate, low permeability reservoirs or whatever, bypassing or removing formation damage that's causing lower permeability reservoir and restricting the flow. So we can use well intervention to solve this problem also. The artificial lift. What is the relation between artificial lift and well intervention? You may need to change or to set a new gas lift valves. In case of Slickline, we will use the Slickline to change gas lift valves and also to set or retrieve jet bombs. Some artificial lift couldn't be implemented or changed by well intervention methods such as ESP. ESP will require a workover rig. Also, a mechanical repair or a well integrity, referring to our well here. If you have some issue in your Christmas tree, a master valve is broken or damaged, and you need to change this lower master valve or whatever. How can you change it? You must firstly isolate the formation to isolate the well pour against the formation pressure. How to isolate the well pour? To change or to make any repair here by setting a plug, nipple plug, which is set by Slickline, 1 or 2 plugs to isolate the formation against formation pressure, to isolate the well against formation pressure. So we need this well intervention to make the mechanical repair and also to save the well integrity. Also, you may need well evaluations. Well evaluations, like we said, PLT, production logging tool, or logging or pressure and temperature surveys to evaluate your well, to be proactive before any problem may happen. So it may happen. So you can go through this well evaluation by well intervention techniques. What are the main advantages of each type? We need to know the feature that the first glance to that it will first come to your to come to your head, or to jump into your mind when you choose the well intervention technique. So when you say Slickline, when you mention Slickline, the first idea comes to your head is mechanical jarring. Slickline, the advantages is its advantage is mechanical jarring. Mechanical jarring because it's a rigid line made from a carbon steel. Sorry. It's a rigid line made from a carbon steel or stainless steel, and has the elasticity and stretching for mechanical jarring. So this mechanical jarring allow us to set or retrieve any subsurface tool, or to do which is called drifting of the pipe, or cleaning through tubing by mechanical jarring. E-line also uses the electrical signal. Here, Slickline mechanical jarring, but E-line use electrical signal. Electrical signal can be transmitted through conductive cable. As we see here, it consists of strands and a core, conductive core, which transmits electrical signal through to receive and send signals downhole which is called surface readout. What can we do with E-line? Perforation, logging, and so on. Any application need electrical signal. The braided line. What is the braided line? The braided line, it's like E-line, but without its core. It's only a braided line, and it's used in higher tension for fishing. Higher tension than what? Than Slickline. The E-line hasn't any mechanical jarring, but the Slickline has a mechanical jarring, so it can be used in fishing operation. Braided line can be also used in fishing operation, but higher than the Slickline. Slickline can be up to 3,000 pound overball, but the braided line can reach to 6,000 or 7,000 overball. So it's used for fishing operation, as we see here. Okay, for digital Slickline, it combines between mechanical jarring and electrical signal. Mechanical jarring and electrical signal. So it has the advantages of Slickline and also the E-line. It's a conventional Slickline, but coated with from outside by a conductive material to allow the mechanical jarring and also electrical signals. Okay, for the coiled tubing, the first idea jumped to our head: coiled tubing for pumping. Oh, this wire line have no ability of pumping, so coiled tubing here has a main advantage of pumping, and also all mechanical application and electrical application done here by wire line can be done by coiled tubing, as we will see on the next slides. Snubbing unit is it's just simulates the workover that we mentioned on the first slides. It simulates the workover application by pulling or inserting tubings into live wells. It's heavy duty and it can be used for recompletion. Okay, let's go over quickly for types of well intervention and have insights on them. For Slickline, objective and application, Slickline is primarily used for routine mechanical operations. Applications include tubing drifting by gauge cutter, or setting or removing plugs. As we said, mechanical operation and the elasticity that enables me to do a mechanical jarring. So tubing drifting by gauge cutters and setting or removing plugs. Basic fishing operations, as we said, fishing operation when we have a stuck tool, this Slickline can be used. As we see here, the rig up over the Christmas tree by installing a PCE, which is lubricants, lubricators, which is lubricators. This lubricators, inside it, we have the string of the Slickline. The string is accessorized by mechanical jarring, as we see. This mechanical jarring do all mechanical operation that we need for gas lift, valve change, or temperature and pressure surveys, but in memory, not live. Basic fishing operation and setting and removing plugs and so on. For E-line, we have mentioned Slickline. Now E-line, electric line. What is the electric line? As we said, it's a cable with a conductive core inside it to transmit and receive electrical signals. We have a real-time data or electrical tools, which is called surface readout. I can transmit and receive data through this E-line and do all these applications and more. PLT, perforation, cameras, caliber logs, setting or removing through tubing bridge plugs by electrical signals, and so on. Digital Slickline, as we mentioned, a conventional Slickline coated from outside by a conductive material. Conventional Slickline coated from outside by a conductive material to allow mechanical jarring and also electrical signal transfer. Mechanical jarring, so you can do drifting the tubing and collecting samples, setting and removing plugs as conventional Slickline. Electrical signal for real-time data, monitoring data while performing the job. Can do production logging tools, PLT, and perforation, and so on. It has some limitation. Digital Slickline has some limitation. We can also mention that it's not strong mechanical jarring action. It will not capable of strong mechanical jarring actions. Why? To protect the conductive coating material. If we make a strong jar, we can lose or fracture the outside coating material. So it has a limitation on mechanical jarring, not very not active or impressive such conventional Slickline. It has a limitation on that. Also, to prevent the tool stuck, as it's a higher cost than conventional Slickline. If you stuck with this with this digital Slickline, the fishing it will be harder and cost more cost than conventional Slickline. Okay, for our hero today, coiled tubing. Coiled tubing can do all the mentioned application before, and also add to them, we can add to them pumping operation. So it can be complex interventions, more complex interventions, and it can be used in live well operations. What is the application? Before discussing the application, I would like to show you a video about the rig up and the concept of coiled tubing. Sorry.
Okay, it appears now.
It's clear now?
Yeah, it's clear now. But it has no voice. No sound.
No sound? Let me share this. Still has no sound.
Yeah, still no sound.
Okay, it's I can describe the video. It still has no sound.
Yeah, still.
Okay. As you see here, the coiled tubing unit is used. It's in this video we will see the surface equipment reel, as you see, and this the injector. It's a continuous pipe, as you see here, is wound around this reel to implement your job. This continuous pipe is used for most of well intervention applications we have mentioned. As you see here, this red pipe is the coiled tubing, and down here is the PHA, whatever the application is used for. There is an on-site on rig up. This a control cabin, the control cabin which have all the controllers that the operator will use to control the movement and the hydraulic operation for coiled tubing. This is called COMPI POP. This POP is installed over the adapter flange on the wellhead, and the completion or the rig up is completed by lifting the injector over the riser or the POP and connecting the hoses here to all these hoses to complete the hydraulic cycle of the coiled tubing, and this is called the gooseneck. This coiled tubing entered over the gooseneck and down here to inside the injector, and the pipe can be injected downward through the tubing. This injector will be lifted over the, it's called, this is the PCE of the coiled tube. And the injector has chains or hoses to snub the coiled tubing inside the well. Coiled tubing reel has some accessories like level wind and counter reading and so on. It will be described later in 5-day course. Okay. Well, back to our presentation. Okay. Snubbing operation. We have now, for coiled tubing applications. As we see in the video, by this continuous pipe lowered into the well bore, we may do a lot of applications, such as sand clean outs and well lifting by nitrogen. This pipe can go downhole to remove any sand fill, as we will see in the next slides, and we can do a lifting for the well or unloading the well by nitrogen. We can also use downhole motors for milling and fishing operations. Milling or fishing operations. Okay, this milling and fishing operations can be conducted by coiled tubing. Fishing operations for coiled tubing has a main advantage of higher capacity of tension. As we said, Slickline can be used up to 3,000 pound over ball. Braided line can be used over 6,000 pound over ball. But the coiled tubing, to know the difference, it can reach to 80,000 pound over ball. It can also be, we have acidizing and fracturing. It can be implemented by coiled tubing. And if the coiled tubing, all the coiled tubing application we have mentioned now by bumping operation. Is the coiled tubing have the ability to conduct real time and sending and receiving electrical signals? Yes. Yes, coiled tubing has this advantage, and we can do perforation and logging by coiled tubing also. Setting plugs, as we illustrated in the first slides, setting the cement plug, which is set by wire line, it can be also done by coiled tubing, and we will know what is the difference between them. For snubbing operations, the objective and application of snubbing operation, the term snubbing means the act of putting a tube into the well bore against pressure through POP. If you see here, this configuration over the wellhead, we can put or insert a tube or a drill pipe, whatever, against the well head pressure, against the well pressure. So it will do the same application for coiled tubing, but in wells with severe condition. Why we need a snubbing unit over the coiled tube application? It's easy to use the coiled tubing instead of snubbing. Because of a snubbing unit, we may use it for severe conditions like high pressure and high temperature wells. If the well head pressure exceeds 5,000 psi, and also for higher or heavy fishing operation. As we said, the coiled tubing may reach to 1,000 or 80,000 pound over ball. Snubbing may exceed 150,000 pound over ball. So it's may required in heavy fishing operations. Let's have now a speed or a comparison between all of these types of well intervention. As we said, setting or pulling plugs inside tubing, it will be preferred by inside tubing. Will be preferred by Slickline. Slickline because it has its ability as a mechanical action to set or retrieve anything inside the tubing. For E-line, it will not be commonly used. For digital Slickline, it simulates the Slickline, so it will be high also. For coiled tubing and snubbing unit, not common to deal inside the tubing, not common. But coiled tubing can be do some application inside the tubing or setting plugs inside the tubing also. Depth correlation, the highest depth correlation with E-line. Why? Because it's live, interactive, real-time data with the well, which is known as CCL, casing cooler locator. CCL or gamma ray are used for depth correlation. So this interactive tools while performing the job give us the most and accurate depth correlation. For a Slickline and it also for digital Slickline, we can use CCL and gamma ray. For a Slickline, it will be the depth correlation will be with error. The depths can be with error and also for coiled tubing and snubbing unit. And so on. For real-time acquisition, as we said, E-line and digital Slickline will be the highest. For Slickline, there is no real data acquisition during the job. For the coiled tubing, some applications, as we said, we have real-time data acquisition. So we will give it medium because it's not on all application. All application have the bumping. Okay, it's not a problem, but in real-time data acquisition, it will be applied in e-coil and active coil. There is some technologies called e-coil and active coil. We can discuss it later, but it simply uses the electrical line with the coiled tubing itself to real-time data acquisition. For snubbing unit, there is no electrical line for sure. Mechanical operation will be highest as we said for the high overpull. The high overpull for mechanical operation and fishing operation, it will be on coiled tubing and snubbing unit, and also for lower for Slickline and not possible for E-line. If you have a perforating, why we mention these differences? Because as we said, as a petroleum engineer, it's your call. You have a decision to select the well intervention method that will attribute for your well. So you must know the weakness and the strengths of well intervention techniques to choose the appropriate technique. So for perforating, the highest technique that will perform perforating is E-line for sure, and it can be implemented also by coiled tubing digital Slickline. Snubbing unit not coming for all types of perforation except for TCB. TCB can be done by snubbing unit, as we said. TCB tubing conveyed perforation. A perforation gun is attached to a tubing, so it can be done by snubbing unit. Okay, for well cleaning, well bore cleaning, when we mention a circulation or pumping, our hero, it will be the coiled tube. The coiled tubing is the most applicable and effective well intervention technique for pumping and circulating downhole. Also the snubbing unit, but coiled tubing will be faster and cheaper. For stimulation also, as we mentioned before, coiled tubing for stimulation. Stimulation can be done by coiled tubing. If we also compare the all types of fluid pumping, so we will choose coiled tubing. And it's important to know that horizontal or high deviated well over 70 degree of inclination, the coiled tubing is the most applicable, and also snubbing unit for horizontal or high deviated well. So the rule of thumb, when you are dealing with a horizontal or high deviated well, you will choose coiled tubing. As we said, fishing operation, it will be the highest capabilities in coiled tubing and snubbing unit. The cost efficiency, the cost. What are the most well intervention techniques in cost? Snubbing unit. Snubbing unit is the highest cost. Then coiled tubing is cheaper. Then digital Slickline and in the last line come E-line and Slickline. Digital Slickline and E-line can be the same. On some application, E-line is the higher cost than digital Slickline. But the most cheapest one, Slickline, and also the highest cost is the snubbing unit. It's like the workover. It's cheaper than workover rig, but it's the most cost well intervention technique. So the speed of operation. The most speed of operation with the easy rig up, with the easy rig up, Slickline, E-line, digital Slickline, which can we call them light interventions. For coiled tubing and snubbing unit, it will be slower, and the most slowest one, snubbing unit. So you can know your application or task or capability you have, and from this you can choose the well intervention technique that we can use. So let's dive in coiled tubing. Coiled tubing, as we said, it's a continuous pipe. The idea of continuous pipe is this pipe wounded around the reel, and this continuous pipe will reach to the bottom hole. So we can bump through it. In snubbing unit, you must join every single tubular or drill pipe or tubing together through the connection. So it will be slower than coiled tubing. Coiled tubing will be faster as it one continuous coiled tubing pipe, one continuous pipe introduced into the well, which is reducing the downtime and can do all applications of cleaning, fluid pumping, nitrogen lifting, and so on. Okay. Pipe sizes normally range from 0.75 inch to 3.5, and it can be exceeded to 4.5, but we mention the 3.5 inch because to run inside the tubing and the casing. To run inside the casing, especially 3.5 inch, it will be run inside the casing. Is everything is clear? Anyone need a question till now? Anyone need a question?
I think no one needs.
Okay. What is the advantages of coiled tubing over the other well intervention techniques? As we said, it requires no rig. In general, coiled tubing requires no rig. It can be rigless. As we said before, workover needs a rig. Coiled tubing can be rigless, which is saves time and money as you don't have to kill the well. What is the problem of killing the well? Killing the well may cause a formation damage. We have someone raised the hand.
Yes, I have
Hello. Good evening from here.
Good
Please
evening.
confirm you can hear me.
Yes, we are hearing you. Go ahead.
All right. Thank you very much, Engineer Mahmoud.
Thank you.
Very amazing presentation there. I've been following through, and I must really say it is very detailed. I just have two questions. My name is Ethelbeth Kelechi Mokocha. I'm calling in from Nigeria. Two things. First, does the viscosity of the fluid, does it really affect the operational integrity of the coiled tubing, like the viscosity of the fluid. I know it may really affect, the flow, the overall flow within the oil rig, but does it really affect directly the coiled tubing integrity structure?
Sorry,
That's my
which
first
type of
question.
fluid? Pumped fluid or the well pour fluid?
The well pour fluid.
The well pour fluid, okay.
Yes.
The
Should I
second
go ahead
question.
with my second question?
Okay.
Okay, yes. Second question, how do you handle how does mechanical failure relate with rusting around the parts of the coiled tubing machinery? For example, is there more like a mechanical allowance that irrespective of a particular mechanical failure, is there more like a mechanical allowance while working with this particular machinery? What is the mechanical allowance that, that does not really project threats to safety per time using the coiled tubing methods? Do you understand the question, sir?
Yes, the mechanical allowance of the coiled tubing itself, do you mean?
Yes, yes, yes.
Okay. Okay, thank you, Elizabeth, for these questions. For the first question, the viscosity of a fluid, of the well pour itself. Yes, of course, the viscosity of the fluid will affect our operations. So in our design for coiled tubing preparation, we have which is called a job planning and a job design. So if you imagine the coiled tubing, we have the snubbing. If we refer to this picture, we have a snubbing force by the coiled tubing. We have a snubbing force generated by the injector. So this snubbing force will overcome any pressure and any viscosity. And also for the effectiveness of the fluid or the how the fluid affect the coiled tubing from outside, there is many inhibitors that introduced into the well during the job, which is the friction reducer. This friction reducer, one type of chemicals that introduced on the coiled tubing, it will be injected through coiled tubing and will flow back. Will flow back during the annulus. So this will be reduce the friction between the pipe itself and the fluid for the well pour fluid. So all these considerations are taken into our calculations before we do the job. Is it clear?
Yes, yes.
Okay. For
yes,
mechanical,
you made yes,
Thank
you
you.
made points.
For a mechanical allowance, yes, of course, you hit the point for the limitations of coiled tubing. We have a limitation of all well intervention techniques for sure. But for coiled tubing, the mechanical fatigue also included in our design and our calculations before the job. This will be discussed in details in a 5 days course, but we can mention it briefly. That is, we have which is called which is called pipe management, coiled tubing pipe management. This pipe management is done by softwares for coiled tubing designing, and we have the equations for it available to everyone to allow to calculate the stress fatigue, the mechanical fatigue, the outside overburden pressure, the inside burst pressure of the coiled tubing, how is the coiled tubing will be overcome its tensile strength and all these calculations. So the mechanical allowance for sure can be calculated and can be taken in consideration before the job. Okay, to continue, now we are talking about the advantages of coiled tubing. As we said, there is no need to kill the well, and also the killing the well may cause a formation damage, and the formation damage may be raise a problem, and we need to solve it by stimulation and so on. So this will be saved by coiled tubing. There is no killing fluid introduced to the well, and we can do application with our live wells. So it can also have the save time and cost, and it can perform the applications and the operations efficiently without any downtime. As we said, optimize job design, we have mentioned it now for pipe management and fatigue management, and also all calculation needed, the speed you are lowering the coiled tubing with, the maximum allowable tension or tensile force, and so on. So what are the main categories of coiled tubing operations and applications? The main categories, we have three main categories: pumping operations, mechanical operations, and also permanent installations. As we said, the coiled tubing is our hero for pumping operation. Any pumping operation you need, you will call off or use the coiled tubing. The coiled tubing here for pumping operations applications, removing fill or sand from the well bore. We will talk about it sooner. Stimulating formation, as we know, acidizing or hydraulic fracturing, unloading the well with nitrogen. This most common used for pumping operation. Any new drilled well may need a lifting operation to initiate the well for production. So this unloading mechanism will be done with injecting or pumping nitrogen to lighten the hydrostatic column of the well bore fluids to initiate the well for production. Okay, as we said, removing fill, removing also any deposits by or scales deposition by milling, isolating any undesirable formation entry with cement, and removing scale, as we said. So all this is pumping operation. Removing the scale by using downhole motors, as we said, and a bit, and the corresponding bit to choose to be effective with the type of scale, and we can use it. Mechanical operation also, we can, as we said here, you can remove the remove the scale by injecting, but not all types of scale can be removed by injection. So we can use it by injection or pumping with using motors, which is milling applications. Also, as we said, fishing operation, as we said before, there is a high limitation of a high capabilities of bowling capacities and coiled tubing, as we can exceed 80,000 pound tension over bowl. Mechanical operation with electric line also can use perforating, or we can use it as a TCP, tubing conveyed perforation. And we can make a logging with coiled tubing? Yes, we can. We can do a logging with coiled tubing. Permanent installation, not very common used, but may be used as which is called velocity or siphon string, and we'll discuss at the last slide, I think. The most common use for coiled tubing application, as we said, the nitrogen lifting and also cleaning. Nitrogen lifting and the cleaning, as we said, the pumping operation is the most widely used. Also, matrix acidizing and well pour clean out and cementing, also the highest or the most common application for coiled tube. If we review rapidly the advantage of coiled tubing over other techniques, coiled tubing versus slickline, as we said, coiled tubing handles more complex intervention, simply a pumping operation. Slickline doesn't have pumping operation. Slickline so simple and cost effective but limited in scope. Coiled tubing has more advantages and applications over slickline. E-line also. The main difference, as we said before, you can, for the first example we have illustrated for water shutoff, we can do it with E-line and we can do it with coiled tubing. What are the main difference, or what are the main criteria that will make you take a right decision using E-line or coiled tubing? The most application we can use E-line for lower cost, for the application that coiled tubing and E-line the both can do, okay? Such as a water shutoff. Coiled tubing can make the water shutoff, and E-line also can make the water shutoff. All the run we have mentioned, BLT, cement plug, through tubing bridge plug, and cementing, pre-perforation, coiled tubing and E-line can do the both. So it's your call to differentiate or to choose the suitable method. I think E-line are commonly used over the coiled tubing in some techniques for low cost and for ease of use. But in some cases, you will choose coiled tubing over the E-line. The most situation you will see for using coiled tubing over E-line, the horizontal wells. The horizontal wells or high deviated wells, because the E-line can't reach to the target bottom. So we will use the coiled tubing for its flexibility to reach to the end of your well. So we will choose coiled tubing type. We will choose coiled tubing for also for coiled tubing will be used over E-line also for if you need a pumping operation with this applications. If you have a milling or if you have an obstruction on the well, that the E-line will be used. So it's logic to use coiled tubing to mill or to clean or to fill or to lift or any fails or obstructions inside the well, and in the same usage we can go with the remaining of the scope of the water shutoff. As we said, for coiled tubing and snubbing, coiled tubing and snubbing, it's similar for pumping and can be used for milling and some drilling applications, but snubbing more heavy duty than coiled tubing, as we said, in high pressure, high temperature wells, and also for any boiling capacities that are exceeding the coiled tubing application. For sure, coiled tubing and workover rigs, coiled tubing will be faster and cheaper for the rather than the workover, but in some cases we necessary to use a workover rig for major repairs or tubing replacement, or as we said, recompletions. So we have discussed this before. The decision-making criteria for you to take the action, the right action, to cool off the corresponding well intervention technique. So some factors we will consider before choosing the well intervention technique. What is the well pressure? What is the well temperature? As we said, high pressure temperature applications will be doable in some well intervention techniques and not for the other. The well geometry, as we said, in inclination, the horizontal well. The horizontal well, we will choose coiled tubing for ease of access. Horizontal well will be preferred to use coiled tubing and also snubbing unit in some applications. Okay, type of job, simply pumping operation, you will use coiled tubing directly. Cost and operation and the location of the job, is it offshore or onshore? Because in some concentration, we can't do all type of well intervention on offshore, because of the limitation of space, the logistics can be difficult. So we can prefer some well interventions over other in offshore. Okay. So let me ask: if there is one hero technique or one technique that can be used alone on all jobs, I think it's difficult to say that is, I will use the coiled tubing for all applications. I will use coiled tubing and cancel or other techniques and use the coiled tubing only. It's not logic and not practical. In our petroleum sector, there is no one hero technique that we will use alone in all jobs. So there is also there are many integrations between well interventions. I have an example here for this integration. Before I will use, for example, a coiled tubing for any application. Okay. Before I move the coiled tubing to our well site, we can use a Slickline. Why we can use the Slickline? Here is the integration comes. Why we are using Slickline before coiled tubing? We can use Slickline before coiled tubing for drifting the tubing, for any obstructions or any unaccessibility. For sure, we can use coiled tubing for this drifting, but Slickline is cheaper and faster. So I will do my job planning correctly. If I know there is an obstruction by Slickline and I'm dealing with this obstruction, so I will use a coiled tubing application right in a right direction. So I will call off the milling and I will bring milling tools and so on. So the rule of thumb, we prefer to do a Slickline job for drifting by gauge cutter inside the tubing before any well intervention, before coiled tubing, before E-line, before digital Slickline. We use the Slickline to drift inside the tube. If the tubing is accessorized with subsurface safety valve, which is called wireline retrievable subsurface safety valve, inside the well bore we may have a subsurface safety valve that it's a device used in emergency, and it can be go through. I can't run into the well bore inside this subsurface safety valve. So I I must remove or retrieve this wireline subsurface safety valve before the job. What is the interventional technique that will be used to remove the wireline subsurface safety valve is the Slickline also. So Slickline here used for drifting the pipe, the Slickline here used for retrieving the wireline subsurface safety valve to go to allow for the coiled tubing to go through the tubing. In some cases, we have to run with a wireline or a Slickline also to measure pressure and temperature surface to make a right coiled tubing job planning and procedure before moving to the well site or well location. Sometimes required to open or close SSD before running with coiled tubing. So all these scenarios ensure and illustrate that there is no one hero technique. There is an integration between all well intervention techniques. For the last section, we can go over some common applications briefly for the coiled tubing. First of all, the fill removal. What is the fill removal? As in this case, we have a huge interval of producing formation. A huge interval of producing formation is plugged with sand. So we need to clean out all this fill or sand fill by using a coiled tubing with PHA. A specialized for clean out is called hydroplasting or hydrojetting. It's high jet nozzles to pumping a fluid from the surface to remove all the sands out of the well from the annulus between the coiled tubing and the tubing itself to up to the surface. We can pump anitrified gel or simply brine water mixed with foam. This will lift the sand out of the well. Okay, here comes a straight fluid or energized fluid. Straight fluid it means only water, brine water, with some of nitrogen. Energized fluid, which is a term used for foam fluids with foam. Okay, for scale removal also, as we said, we can have in this scenario sand fill, we can have a scale at the end of the tubing, during tubing accessories, at the formation. So we need to remove the scale by milling. As we see here, we will use a downhole motor, which is called PDM, positive displacement motor. This motor is consisted of rotor and stator, whatever. So you have the ability to rotate this motor and correspondingly rotate the drill or the bit itself by pumping fluids from the surface. You have the two advantages of milling operation and also cleaning operation, milling and cleaning at the same time. Nitrogen application, as we said, for nitrogen lifting, which is called production kickoff or unloading. This production kickoff from a new drilled wells by injecting nitrogen from the surface inside the tubing and then lifting all the fluid or the hydrostatic fluid to allow the formation fluid to enter the well bore by reducing the hydrostatic head and make the well to flow, which is a loading process, as we said, by injecting nitrogen nitrified gel or energized foamed fluid with foam, and this will be have all the hydrostatic head to be out of the well, or to lighten the hydrostatic head to allow the formation to be produced. As we mentioned before, coiled tubing are used for fishing operation, not only conventional fishing used by slickline or braided line, but in heavy fishing, which is the pulling capacity, as we said, over 100 or 80,000 pound. We can overpull any stuck. And if you see here, there is a fish, and this fish is stuck inside some scale or some sand or something like that. So we will use a coiled tubing with all this PHA. At the end of this PHA, this have some details, but we have not enough time to mention it. But briefly, it's which is called an overshot. This overshot will latch or will catch this fishing net, and by upward jarring, we can retrieve the lost string due to high pulling capacity. Some of techniques also inflatable packers. What is inflatable packers? In normal stimulation techniques, we can use which is called ball heading from the surface by bumping, and the all acid. If we have, as we see here, 3 or more intervals. All acids or most of acids will go through the highest permeable formation. If this the highest permeable formation, so the acid will go through it. And if this is low permeability or has a formation damage, the acid will willing to go for this formation. So we can use in this situation, which is called inflatable packers. It's run through coiled tubing, and it can be set by hydraulic bumping from the surface. So it will this inflate, as we see, and isolate bottom and up of this target formation. So we can inject the acid inside the formation and isolate other formation, not as we call it the thief formation. This thief formation with high permeability can take all the acid, but in this case, with this isolation, we can bump through this coiled tubing to target zone with a smaller volumes. What is the chemical diverters here? The chemical diverters, which is used in case of not using the coiled tubing by normal acidizing, to temporarily block this safe zone and directing or diverting acid to the lower permeable zone. So in this case, with inflatable packers, we don't need chemical diverters. Also, coiled tubing perforation. As we know, there is many types of perforation techniques. One of them, which is important for underbalancing, coiled tubing TCP, tubing conveyed perforation, which can be run by coiled tubing or any other tubing techniques. So tubing conveyed perforation is the gun is attached to a tube. In this case, we are using the coiled tubing. So the coiled tubing here will give us an advantages for high deviated well, as we said. In case of wireline perforation, the normal wireline perforation, which is run over E-line, the wireline perforation can't reach to the high deviated wells, so we can use coiled tubing perforation in this applications. Stimulation and chemical treatments also as we said, by bumping acids or hydraulic fracturing to the target zone. If we see the difference between the two pictures here, we see this on the left-hand side. This is the normal bumping. We bump in the acid from the surface till the formation. But here we use a coiled tubing. The coiled tubing is injected to the target perforation. If we perforation here or the formation here will be pumped during this target zone and save all the treating volumes to the target zone by injecting the coiled tubing in the right location on the target location. And also after pumping the acid, we need a cleanup for cleanup for the this pumped acid and this formation damage and this diapers, so we can use the coiled tubing to lift all the formation fill to be cleaned out by pumping. So we have two advantages here. We pump the acid to the target zone and saving the treating volumes and also clean out after the acidizing. The last application not commonly used, which is called siphon coiled tubing or siphon string. It's a smaller, it's a permanent installation of coiled tubing inside the already existing tubing. Because of production decline or lower BWF, we can use a smaller coiled tubing to produce permanently through the coiled tubing itself. The well will producing through the coiled tubing itself and the isolation by means of buckers here to produce for a smaller inside diameter than the existing tubing to using nodal analysis to make a production optimization with higher bottom hole flowing pressure and to save our production. Here we have one or two case study briefly. We have an offshore gas well with sand accumulation. There is two ways to use sand removal. With the coiled tubing, as we said here, the sand fill. If we use the coiled tubing, we will clean all the fill in less than 24 hours, less than 12 hours. After rig up time and the operation time, it can be 12 hours or lower than 12 hours. But if we use another technique such as a slickline, we can use we can go through the well with the slickline and have at the end of the slickline the PHA, which is called baler. Baler, it's like a container or something like that to remove the sand trip by trip, and we can remove 1 or 2 feet per trip. So it will take days, not 12 hours only. So in this case, we used coiled tubing and the production restored in less than 24 hours. Zonal isolation, I already mentioned in the first of our presentation, coiled tubing and wireline. The coiled tubing spotted a cement plug and a perforation also done, so it will production improved by 40% production recovery, and also it was a high deviated well, so it can't be done by wireline. We are now and at the end section of our presentation, so I'd like to thank you, and if you have any questions, I will hear you.
Thank you, Engineer Mahmoud, for this wonderful session. It was really fruitful and I really enjoyed it. We will have like 2 minutes break just to fill in the feedback form that I will send in the chat box and let the attendees prepare their questions, okay?
Okay.
Okay, peace. We will start taking your questions after 2 minutes. Okay, so we have the first question from Engineer Muhammad. He is asking if we could run ESP with coiled tubing.
ESP is a part of completion. If we imagine the completion is the box and bin can be joined together, and one joint of them is ESP. ESP is installed as an integral part on the completion itself. So, can we run this ESP by coiled tubing? It's not applicable because the ESP itself has a completion integral part. If it has any damage or malfunctions, so it will be replaced with the completion itself. So we need to remove all the completion by workover rig or snubbing unit can use it to pull all the completion out of the well and replace the ESP. Recently, some cases recently they invented some applications of through tubing ESP, but it's not commonly used till now.
Okay, thank you, Engineer Mahmoud.
Okay.
Please, you can ask your question now.
Okay. Good evening, sir.
Good evening.
Thank you, Engineer, for the wonderful session you just gave to us.
Thank you.
I'm actually joining from all the way from Nigeria, Port Harcourt. My name is Peace Emeni. I have some questions to ask as regards the session. Can you hear me?
Yes.
Now, looking at a production packer during completion session, looking at the production packer, you can set the packer hydraulically and mechanically.
Yes.
Are you with me?
Yes, yes.
If you want to set the packer, how do you set the packer using your Slickline operation? What and what need to be put in place for you to set that packer using your Slickline operation? That is one of the questions. And
Yes.
the second question goes like this. How do you use Slickline operation to bring other zone in line?
To bring what?
Other zones, like now you can have multi-zone production, right?
Multi-zone production.
Yes. So take for instance, you are producing from zone A, which is pay zone A.
Yes.
And you want to bring pay zone B or C into production now. Initially, per zone A and per zone B and C, they were not producing, but now you want to bring them into production. Now, how do you use Slickline operation to bring this per zone B and C into production?
Okay, the zones P and C underneath the zone A or over them, and there is tubing or one single tubing or multi tubing. It's
You
depend on
have
the
it
condition.
as okay. You have it as a single zone completion, not multi
Yes,
zone completion. Single,
yes.
because we are also looking at cost effectiveness. So how do you use this a single string to produce other string to produce multiple zones?
Okay. Let's see if we have this presentation again. Sorry.
Hello?
Okay, I will answer you by sketching some. There is a problem with my. You see this? This white paper. Do you see this paper?
Yeah, yes, and with piece
Okay.
of paper.
Yes, for your first question about
Production packer.
packer, yes.
How do you set your packer? Because you can set your packer hydraulically or mechanically.
Yes.
So how do you set this packer? Because setting of your packer, you can set it hydraulically for the elastomere, which is the element to come out and seal up the annulus. Are you
Yes.
with me?
Yes,
Now
yes.
you can as well set it mechanically to ensure that this the slip on the packer grip on the wall of the casing of the production casing. Are you getting me?
You want to know how to set the packer with the Slickline?
Yes. How do you set it hydraulically? How do you set
Yes,
it using your Slickline operation?
Yes.
How do you set the pack hydraulically?
Let's say it's in workover completion. This is a setting packer.
It's a new completion, sir. New completion.
Yes. For the new completion, you have a workover rig, or sorry, a drilling rig in a completion phase. You have just finished the drilling. You have drilled your production tubing and the production casing, and you fixed it to the target zone. You now are running with the completion, with the tubing itself. So it will fix your packer by means of pumping hydraulic pressure. This hydraulic pressure will activate this slips to inflate the packers outside the tubing. Against what? Against what it's called at the end of the tubing, the surge disc. Surge disc. What is the surge disc? It's a ceramic disc that isolate the end of the tubing, and when you pumping the fluids from here, the packer will be set. For a Slickline drifting inside the tubing, and at the end of the setting the packer, you will break the surge disc by Slickline bar and allow this hydraulic column to settle down to the formation, and the hydraulic packer is set. There is another way by Slickline to set a through tubing plug. This plug is set at the lowest nipple in the tubing, which is maybe XN nipple. This plug.
Nipple, yes, that is what I want to hear, sir. That
Yes,
nipple,
yes.
have the SN nipple or the
Yes.
SN?
Yes, XN nipple. Yes, the XN nipple. The XN nipple has a inside diameter
Yes,
with
no go
yes,
outside.
yes, inside diameter with let's say in 3.5 inch, 2.63, whatever. It's this
Okay.
this nipple has a no-go nipple. This nipple has
Yes.
a no-go profile, and the lock mandrel itself has also the no-go profile. This no-go will meet this nipple at this point and make a sealing with a backing, yes, backing inside the plug itself. And by raising the pressure here, you can filling this this tubing with a hydraulic and raising the pressure to set the hydraulic pucker. When you set the hydraulic pucker, you go through again with a Slickline and retrieve this plug by means of equalizing first equalize the pressure to drop all the hydraulic pressure down the plug and retrieve the plug. There is another way, it's called a bump out plug, which is commonly known with FP2 plug. It's a one-way, yes, it's a one-way check valve, that will hold the pressure from upside only, from upside. So when we pump pressure here, it will hold the pressure, and set the hydraulic pucker, and then after setting the hydraulic pucker, by jarring up, it open ports to equalize pressure down the pump plug, and we can retrieve them again. Is it clear?
Thank you, sir.
Thank you.
It's very clear, sir. Very, very clear. So the second question, should I take it again? Or you are still
What
with
is the second question? I forget the second good.
Okay, the second question is this. I said you have, because the essence of these oil producing companies, they are not just into business. They want to make
you
profit.
have
multi-zones.
Yes, you have
Right?
multi-zones.
A completion there is one we call intelligent completion.
Yes.
Now I have a completion and I want to use just only one string, only one production tubing to produce 3 pay zones. I have pay zone A, B, and C. And probably I was producing just only pay zone A. Are you with me?
Yes, as
now,
sketch.
As time goes on, I discovered that there is a drop in production rate, and I need to make money. I need to maximize my money as the owner of the well. So I want to produce from B and C now, in addition to that A. How do I use this Slickline operation to bring in the pay zone B and C into production?
Yes. Is this figure clear here? A, B, and C. You already produce from A, and you want to produce from P or C, or B and C.
Yes, B and C.
Okay, it will be challenging for many reasons, but there is a solution for it. First of all, is the pressure of P and C and A different pressures? So
different pressure? Yes. Different zone.
Yes, different base zones. So it can't be open to production together, because will be a cross flow from higher pressure to the lower pressure. Is it right? So we can use which is called a straddle bucker. Do you know the straddle bucker?
Yes.
Yes, the straddle packer, it's like this short tubing with a packer from here.
Okay.
This packer is set,
Okay.
and it will make this P, this formation B, producing with A.
Okay.
And if you have an SSD, يعني if you have here an SSD and you have another formation here, you can open SSD and produce from this formation also.
Yes.
But for this situation, the best option is a straddle packer. A straddle packer will allow the formation to flow from this tubing and then enter this tube. And also you can isolate some of them. You can isolate A if it's a depleted reservoir, and to prevent cross flow, you can cement squeeze against this formation to isolate the lowest permeability and allow for the higher permeability to produce.
Okay. If I may ask a question now, there is
Yes.
a kind of intelligent completion. Are you with me? An intelligent completion.
Yes, yes.
Whereby you use your E-line to run down your subsurface control sensor.
Yes.
Are you getting me? To
Yes,
control
yes.
the downflow, your
Yes.
pressure, and all the rest. So is it not possible for you to use this a kind of downhole sensor and valve, downhole valve also, to see that there is no, how will I put it, there is no bottleneck between these three pistons in the
Yes,
subsurface?
yes, of course. It's not applicable in our region till now. As you know, it's somehow new inventions. But I know what are you meaning, that there is smart completion which can be to activate, open or close these valves against
Yes.
the required formation to produce whatever you want. That's right. But
That's
it's يعني a new technique and need a new completion to be run.
Okay.
thank you, Engineer Mahmoud, for this answer, and thank
Thanks.
you, Engineer Beast, for contribution.
Thank
We
you, sir.
have a question from Engineer Muhammad Ilyas. He was asking if we can shoot TCB guns with coiled tubing instead of magnet bore.
Sorry, I will read the questions with you. Sorry. What is
If
the
we
question
can
again?
shoot TCB guns with coiled tubing instead of magnet bore.
If we can shoot. If you can
Yes.
shoot, عادل? Yes. If you can shoot what?
TCB guns with coiled tubing instead of magnet bore.
Yes, yes. As we mentioned, TCB are mainly used now with coiled tubing by either by firing the head hydraulically or mechanically, electrically. Hydraulic firing head with pumping the required hydraulic pressure inside the coiled tubing itself until reaching the firing head activating mechanism by there is a small surge disc inside the firing head, and this is allow the hydraulic to initiate the which is called the detonation mechanism. The detonator will give the action for the firing head to shoot the explosions. And there is a mechanical way, but it's not commonly used now, a mechanical way for firing this head by entering a slick line inside the tubing itself and hitting the firing head by the slick line, which is a mechanical bar and also can be dropped from the surface, but it now in most application obsoleted. This is mechanical jarring with a slickline can be mechanically firing the firing head in TCB.
Thank you. We have two questions from Engineer Mujahid. He was asking, what is the limitation of coiled tubing with regards to horizontal wells? And the
Yes.
second question is, what is the longest horizontal section length?
Okay, for the coiled tubing application on horizontal well, as we said before, it's the most applicable for well intervention techniques is the coiled tubing. But there is a limitation of sure. For the coiled tubing, there is a coiled tubing which will be on the lower side of the horizontal section itself. So it will have some resistance and may cause, which is called a helical or buckling the coiled tubing itself. This helical waves, which will be make an obstruction for more coiled tubing intervention lower than more and more lower than during the horizontal section. For this obstruction, we can deal with coiled tubing. There is a technique called a tractor, which is simply like a jarring or something to stretch this helical or this helical or this buckled coiled tubing to go more deeper in horizontal well to overcome or avoid this problem. For lenses, there is a larger lenses we can reach with coiled tubing over than 100 feet, but it can depend on our application. For perforation, we can divide it into multiple shots rather than a single shot to shorten the length and so on.
Thank you. The last question for today from Emmanuel. He was asking if does every coiled tubing operation require a pumping unit, a cement unit, he means?
Okay, as we said before, we have main components and main surface units on coiled tubing operation. It's not logic to go and campaign for coiled tubing without bringing a pumping unit. It will be an essential pumping unit. Yes, if you can do it without pumping unit, some applications you can do it without pumping unit, such as a dry tag. You will run into the hole to a cement plug or dry tag, a sand fill, or something like that. But after that, you will need a pumping unit to pump the fluid inside the tubing. So it's as an emergency cases, you need to kill the well. In emergency case, if you stuck with the coiled tube, so you will need a pumping unit. So in all applications, you should bring the pumping unit, whatever the application you will use to pump a fluid. And in cementing operation, you will need also the cement unit, of course.
Okay, thank you, Engineer Mahmoud, for answering, and thank you for this wonderful session again. And thanks to all of you for attending today's webinar. Don't forget that we will be running coiled tubing operations live course starting on next Saturday. So make sure you enroll in it. Thank you again and see you in our next webinars.
Thank you.